So our meeting today will focus on how to model frames and trusses on RISA. Let's start with frames. We have a frame here. This frame is fixed support at A. Fixed. We have vertical column and horizontal beam. The cross section of this frame is W10 times 30 wide flange made from steel. It's not our topic in this course. What is the meaning of cross section? What is the meaning of W10 times 30? We will learn all of this stuff in more details next year. Anyway, we have horizontal load 1 kip, 1 kip, and 0.5 kip. We have uniform distributed load 250 pounds per foot. We need to get the shear force diagram, bending moment diagram, reactions, and the axial force for this one. Do you remember, guys, the first step to use RISA? We are going to assume this joint or this point is the origin. So I will put x-axis and I will put my y-axis. What do you have of joint or nodes? Probably we have this node. I will assume another node here, another node, another node, another node. I have question. Why this node? For one reason, because I have horizontal concentrated force 1 kip. Why this node? The same reason, 1 kip. Why this node? Because we have end of member and another member, so we have connection between two members, and also we have concentrated force. And why this node? The end of the member. Can you tell me what is the coordinate of point A? 0x, 0y. What is the coordinate of this point? 0x, 3y. What is the coordinate of this node? 0x, 6y. What is the coordinate of this point? 0x and 9. What is the coordinate of this point? 6x and 9. Let's try. Let's try. If you open RISA 2D, I don't like this grid, so you can hide it by view drawing a grid. How can I start to insert the point? You said insert. So insert, joint, enter first node 0, 0. Enter second node 0, 3, 0, 6, 0, 9, and then 6 and 9. There you go. Next step. So if you remember, first step, we need to define the joint coordinate. From insert joint, you need to define your joint coordinates, and you will find these nodes. The next step, we need to define what is the cross section and draw members. Insert member. Guys, everything you can get it from insert member, or we have another option. You can use this little icon. If you push it, you can get the same window. So we have two options right now. Push this little icon or insert members. Both of them works. The material right now is hot rolled. Hot rolled. Push this little icon and go ahead and select. Just to remind you, the cross section is wide 10 times 30. Okay, go ahead and select wide flange, WF. Meaning of all of these cross section, you will learn them next year. Don't worry, in steel design course. So we are looking for 10 times 30. Here you go. W 10 times 30. Okay. W 10 times 30. Apply. Go ahead and start to draw your members. We have this L shape for truss. That makes sense? So guys, insert member, or you can use this little icon, hot rolled, push this little icon, and you choose from here 10 times 30. Okay, go ahead and draw your members. The following step is insert boundaries. Do you remember boundaries? We have roller, bend, fix it. So I will choose fix it. Apply and put fix it at this node. We have only one support, fixed support. Insert joint load. Guys, I have a question. Anybody can tell me what is the direction of this force? What is the direction? Is it in X direction or Y direction? What do you think? Any answer? 1 kib, 1 kib, 0.5 kib, all of these forces, in which direction? X or Y? Do you know? Is it in X or Y? Any answer? These forces, 1 kib, 1 kib, 0.5 kib, what do you think? They are horizontal forces. So they are in X, in positive X. So, thank you. So direction, don't forget to change direction. Don't forget to change direction. It will be in X direction. How much? 1 kib, positive, 1 kib. Apply, we have a force here. I have another force here. Do you think I need to click here? No, because the value is different. This one is 0.5, so I need to make scale. One more time, insert, joint load, change the value to be 0.5, apply, make sure direction is X, apply, and put another force. The type of load here is distributed load. How much? 250 pounds, but we are talking about kib, so it will be 0.25 kib per foot. So, do you remember how we can define uniform distributed load? Insert distributed load. Your direction is Y, negative. The start value is 0.25. I'm sorry, I forget negative. Start location 0, end location at 6 feet. Apply, just click on this member. There you go. So, after you define the fixed support, I define the concentrated load, which is called joint. Don't forget to change the direction in X. Okay? Probably these units are bound, so I put in bound, but my unit is in kib, so I used kib. Anyway, uniform distributed load in Y direction, and put your values. We are ready. Before starting to solve, do you remember spreadsheet, load combination, enter, basic load combination, it will be basic load case 1, and the scale factor is 1. Once you are done, close the window and start to solve. This little icon equal, solve. We are done. We are done. We have 3 different results. The first one, let's try axial force. Here you go. If you would like to hide the applied load, hide them. Here you go. Here is the normal force. We have compression on this member. How much? 1.5. Kip. We don't have normal force on the horizontal member. Shear. Here you go. Here is the shear force diagram. Bending moment. Here is the bending moment diagram. If you would like to show up the reaction, okay, let's start with the horizontal reaction, X direction. We have horizontal reaction here, 2.5. 2.5. Vertical reaction in Y direction, we have vertical reaction, 1.5. This support is fixed, so we expect we have moment. We have a fixed reaction moment here, 18 hip foot. So I can show up the horizontal reaction, the vertical reaction, and the moment reaction because it's a fixed. Deformed shape, if you would like to show up the deformed shape, here is the deformed shape. None. None. If you would like to go back to the applied load, go back and hit this little icon. Here is the applied force. And the last meeting, I taught you how to get these results to a Word file. If you open Word, here is the Word file. Here is the results. Open from Windows snipping tool tab, and then you can make a window around this diagram, copy it, and go to the Word file and put it here. So here is the applied force. You can put the normal force, the shear force, the bending moment, the deformed shape, all of these stuff. Do you have any question so far? Do you think there is a big difference between beam and the frame? The only difference between beams and the frame, in frame we have coordinate in X and Y sometimes. But in previous problem in beams, if you remember it, everything in X. We don't have anything in Y. Everything in X. So if you put here X and put Y, most of the time coordinate Y is 0. But we have an X at 10, 0 at 10, 16, and 26. Anyway, any question, guys, so far? If you have any question, let me know. Here is the axial force, shear force, bending moment. Here is the horizontal reaction, vertical reaction, and the moment as a reaction. Let's try trusses and see what is the difference between trusses and frames. Do you have any question? Do you have any question? Okay, as I told you guys, it's a good chance to learn this software. We spend more than 6 weeks learning how to solve beams, how to solve trusses, how to solve frames. In few seconds, you can solve your structure on this software. This software in few seconds can tell you what are the reactions, what are the diagrams, what are the deformed shape. Probably next week or the coming weeks, we will start how to figure out this deformation. We will spend more than 1 hour or 2 hours to solve a problem to figure out how much this deflection or rotation. The software can give you these numbers in few seconds. Okay? Okay. File, new, no, no. Oh, sorry. New. I will start a new model. The new model will be about truss. We have this truss. We have this truss, hinge at A, roller at E, applied load 400 pound, 400 pound, 400 pound, 400 pound, 400 pound. We need to define this structure on RISA to figure out what are the reactions, what is the internal force in each member. In each member. Let's start. Let's start this problem. First step, I'm going to define this joint as origin. Here is the x-axis, here is the y-axis. We have many joints. We need to define this one, all joints, all of these joints, we need to define them. This one, this one, this one, and this one, and this one. Okay, go ahead. The first joint, 0, 0. Joint B, 8, 0. Joint C in X, 16, 0. Joint D, 24, 0. Joint E, 32, and 0. Joint H, 8 in X, 6 in Y. Joint G, 16 in X, 12 in Y. Joint F, 24 in X and 6 in Y. Let's start. Let's start. View, drawing a grid to hide them. Insert joint. First one 0, 0. Second one 8, 0. 16, 0. 24, 0. 32, 0. Then 8, 6, 16, 12, 24, 6. Here are the joint of the truss. What do you think? Looks like the truss? Exactly. These nodes looks like this truss exactly. So first step, we need to define the joint. Here are the joint coordinates. I assumed my coordinate at this location. Next step, we need to define the member and draw them. Insert members, hot rolled, this little icon. I will go up to choose W10 times 30. The members is W10 times 30. The cross section, white flange. Anyway, 10 times 30, okay. Before apply, we have something here very important. You have to choose this option. Release codes. Bend at both ends. If you would like to draw truss, you have to choose this option. Apply. Go ahead and connect between members. Can you see each member has two circles, one at the beginning, one at the end. That means you are drawing link member, you are drawing truss members. Keep going. Keep going. Draw exactly for trusses. Here you go. This shape looks like this shape. Please, if you have this node printed, please don't forget this option. Before starting to draw your members, you have to select bend at both ends. Why? Because this option means you are drawing truss members. If you didn't choose this option, believe me, you are drawing frame members. If you remember a few minutes ago, we are using the same technique in drawing beam, in drawing frames, and the same for drawing the truss. But the only difference, you have to select bend at both ends. This option means you are drawing truss members. We have only axial force, no moment, no shear. We have hinge at this node, we have roller at this node. So insert, boundaries, we have pin, apply at this node. Insert, boundaries, we have roller, apply at this node. We have concentrated load, 400 pounds. Actually, my units are kept, so I will use 0.2, 200 pound to 0.2 negative. In Y direction, apply 1, 2, is it 200 or 400? I'm sorry. Insert joint load negative 0.4. I'm sorry. Apply 1, 2, 3, 4, 5. I am done. I am done. Spreadsheet, load combination, basic load case, 1, scale factor 1, close this one, this window, and then go ahead and solve. There you go. Let's start. Anybody can tell me what are the internal forces in truss? Are they axial force or shear force or bending moment? For truss, do you remember? We don't have moment. So if you select moment, nothing will happen. Nothing. Because we don't have moment. If you select shear, nothing will happen because we don't have shear. If you select the axial, here you go. Here is the axial force. Here is the axial force. The normal force in this member, 8. I'm sorry, 0.8 kib. In this member, it's 1 kib. In this member, looks like 0.7 kib. I have question. What is the internal force in this member? How much? In this member? Looks like 0. And also this member looks like 0. That makes sense. Do you know why? Do you know why? Because at this joint, we have 3 members. 2 of them are collinear, no external force. The third member will be 0. That makes sense. This member is 0. For this joint, we have 3 members. 2 of them are collinear, no external forces. The third member should be 0. That makes sense. This member is 0. So what you learned in trusses, here you go. Reactions. We can see here none. If you would like to hide the applied force, okay, go ahead and click this icon. Horizontal reaction, we don't have horizontal reaction. Vertical reaction, here you go. Here is the vertical reaction. If you'd like to show up the deformed shape, here you go, the deformed shape, but it's very, 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 very small. If you would like to zoom in, this icon, deflection, we have something here called the magnification factor, make it bigger, 1000. for example. There you go. If it's still small, go ahead and make it 10,000. There you go. The structure will not be deformed like this, but I'm zooming in, just zooming. Okay. So please remember, 4 trusses, 4 trusses, 4 trusses. You have to select this option before drawing members. If you select this option and start to draw, each member will have to circle, one at the beginning, one at the end. Means you are drawing truss member. Means if you would like to show up the shear force diagram, will show 0. If you would like to show bending moment diagram, it will show 0. The only results is axial, which is internal forces in truss members. That means you are drawing a truss. If you did not select this option, that means you are drawing frame or beam or something else, not a truss.